Hi, I'm Paris, and today I'm not only doing a review of a product, I'm doing an experiment, which makes it that much more fun. This is the Atomic Lighter. It's a plasma arc lighter. It uses electricity to create little plasma beams that you use as a regular lighter to light things on fire. This is a little bit fancier version of the Everlight lighter. This is also an arc lighter that I recently reviewed, but it only has a single arc across it, whereas this has that super cool X-shaped dual plasma arcs. After researching quite a bit online, I couldn't find anywhere where a person conclusively explained exactly how that X gets formed, so I'm going to find that out in this video and see how this works as a lighter.
Epic Review Guys.
The Atomic Lighter is the as seen on TV version of this popular lighter technology that's replacing Bic lighters and any lighter that uses butane. You don't have to deal with messy or flammable fuels to refill it. You simply recharge it. It goes for about $20. You can find out more about it at the link down below this video. In the package is the lighter. Very heavy, much heavier than I was expecting. About as heavy as the Everlight, which has 4 AAA batteries in it, and a short USB charging cable. Here's the Atomic Lighter with the lid. That's as far as it opens. I was looking for something over here to press to light it up, but no, the power button is this little round button right here. When you press it and hold it, the arcs will light up, but only for 7 seconds. I think they shut off automatically to prevent overheating, and then you can press the button and do another 7 seconds if your item hasn't yet caught on fire. On the bottom, there's a safety switch. You slide on and off when it's in the off position. Even if the button's depressed to activate it, it won't turn on. And under this little rubber piece, that's where your USB charging port is. It's a pretty cool looking lighter. I noticed with this color scheme of the black and yellowish green that's become the fashion these days. Needs to be charged up before you use it for the first time, so I'm going to go plug it in. Takes about an hour to get a full charge, and there are indicator lights that will show that. It did take about an hour. I've fully charged up the Atomic Lighter. Or if you can do that flicky thing with your thumb. All right, ready to see the amazing Plasma X. Safety actually works. Good to know. Okay. I do wish this would go further back. It's definitely making an X. You can hear the sound that goes along with it. And how does it do as a lighter? That's how you do it, right? I would say this actually lights quicker than the Everlight because of having the X arc. Gives you more power, more heat, lights faster. The Atomic Lighter is wind resistant. Makes funny sounds, but it keeps on going. And it doesn't matter the orientation. The flames work just fine. I feel a little bit of heat coming up over my fingers. But it's not like with a regular butane lighter where when you have it upside down, you're trying to light a candle or something, the flame is coming right up over your fingers. And it does have the heft of a nice lighter, but it doesn't have the width. Bigger lighters just fit in your hand a little better. This is sort of like the newer iPhones, I feel. They're just too tall and thin. Okay, I've got the ceiling fan on high. Quite a breeze in here. Let's see how the Atomic Lighter cares for that. Noisy, but still making the X. Can it light a piece of paper on fire while it's doing that? I wondered if I slid the paper through it suddenly, if it would block the electrical signal and so it would sort of put the fire out. Let me show you what it did. Right here, I just stuck it right into the lighter to block both of the electrodes and it burned holes right through them. Might be too windy to actually get a fire going because the paper will just blow out once it catches on fire. Or else it will ignite and burn suddenly and rapidly. Okay. I've turned the ceiling fan down. After I saw what happened with the paper, I was curious, what about a piece of cardboard? Something that stays together long enough to block the path of the electricity. I'm going to slide it right through. Oh, it doesn't stop it. It still burns right through it. How does it do that? Now in my review of the Everlight, which I'll link to at the end of this video, I did try it out with sparklers, which are notoriously hard to light. And they were old sparklers and they combusted very quickly and almost threw me off my seat. With this, without the extra distance between my hand and the lighter, I'm not going to give it a try. The atomic lighter should work fine for lighting a burner on a gas stove or a gas fireplace. However, you sometimes get that quick flame up with those, in which case you may have to sacrifice some hair on your hand or arm. That's when you want a lighter like this. So I tried every camera we have in the house, including my phone, in high-speed recording mode, trying to get 120 frames per second, 240 frames per second, to try and capture what's going on with the plasma when it goes to make an X. The reason it's such a mystery is the shortest distance between the electrodes should have it going like this. You should have two parallel lines. And I couldn't find a Bill Nye approved explanation for online for how they do that. So I thought, well, I can figure this out if I can just capture what's going on, slow the speed down enough, and see what's going with what. So here's what I found. So why don't the arcs go straight across? Take the shortest path. Well, here's how they start out. You can see the lines of electricity going up to the other electrodes. Nearly there, and they're forming an X at this point. How is that happening? There's the fully formed two arcs forming the X. And there's video when I'm blowing on it to disturb the flow. You can see the individual white lines. I'm thinking those are the actual, and in this picture, the actual lightning bolts of electricity zapping back and forth. Now look at this. Here we actually have the plasma going straight across, taking the shortest path. Here too, this is on the way to developing the X. And here you can see the lines straight across are fading out, and you end up with the same X. How is it sometimes it can start with them going straight across, sometimes it can start with them forming the X? This is at the end as I've let go of the button. Now the electricity has stopped shooting across, and the plasma, the heated air around the electrical charge is dissipating and basically going back up towards the electrodes. So what did I learn in the end? That I need a camera that can record 480 frames per second. I was just looking at the gap in the electrodes between these two, and the single arc lighter has a wider gap, so you could fit something larger in between them to try and light it, which then got me to thinking, don't try this at home. I don't know if I'm going to try this at home, but I thought, what if I had them both going and put the electrodes near each other? I wonder what they would do. Eye protection and an extra fire extinguisher. That's what I'm adding to my Christmas list. The atomic lighter goes for about $20. It's pretty cool and it's handy to take with you. You certainly wouldn't want to try to fit this in your pocket. Find out more about it at the link down below this video. I'll see you on the next review.